remember this, when dividing terms with exponents that have the same base, and I'm going to switch colors so that it stands out what we're going to do. In that case, we simply subtract the exponents. So I know it looks like a bunch of rules, but really there's a lot of symmetry here. If you're multiplying them together and the bases are the same, you add the exponents. If you're dividing them and the bases are the same, then you subtract the exponents. So if you're multiplying, you add exponents. If you are dividing, you subtract exponents. Only if the bases are the same in both cases. If the bases are different, there's nothing you can do. You can't simplify that anymore. So just to give you sort of an example of this case, what if I had 2 raised to the 4th power divided by 2 raised to the 2 power, 2 squared? Well, I look and I say, well, the bases are the same, so I should be able to do something here. And all I have to do is write the base down. The base is always going to be the same, and I subtract the exponents. 4 minus 2. So that's going to be 2 raised to the power of 2. You always start at the top and subtract off the bottom exponent. That's the way you do the subtraction, top minus bottom. So this is 2 squared. Now, we should at least once figure out why this works. So let's rewrite this here. 2 raised to the 4th power, what would that be? 2 times 2 times 2 times 2. That's 2 to the 4th power, right? Divided by 2 squared. 2 times 2, right? 2 squared. Now, we're going to talk about this a little bit more, but if you think about it for a second, all of these numbers are multiplied on the top, and all of these numbers are multiplied on the bottom. So if you notice here, all of these 2's are multiplied in the top, and all of these 2's are multiplied in the bottom. And so, you know, when you think about it, 2 divided by 2 is 1, so this can sort of cancel out with this. It doesn't really disappear, it's just that when you do this division there, it's going to be equal to 1, so they're going to effectively disappear. This 2, for the same reason, can cancel with this one. This is sort of a general rule that you're going to need to understand. We're going to talk about it as we work more into pre-algebra. Anytime on any fraction at all, if you've got stuff multiplied in the top and multiplied in the bottom, and you have the same term in the top and the bottom, just like we have a 2 here and a 2 here and a 2 here and a 2 here, you can just strike them out because they, in effect, are not going to matter. So in the end, what we're going to have here is 2 times 2, which is 2 squared, which is what we got for our answer, which is going to be 4. So make sure you understand that. We're going to talk a lot more about cancellation you know, as we start to work more with fractions later, but really it's no different than, you know, what if you had the fraction 3 divided by 3? What would that equal to? When you take 3 divided by 3 in your calculator, well, that's equal to 1, right? Well, what if I had, just as another example, 3 times 3 divided by 3 times 3? Well, you know that I could do 3 times 3 and I could get 9, and I could do 3 times 3 and I could get 9 on the bottom, and you know that 9 divided by 9 is big fat 1, so you know the answer is 1, and that is one way that you could do this problem. But another way that you could do it is just to recognize, look, in this original fraction, I have a lot of stuff common to the top and the bottom. 3 can cancel with 3, they're going to divide out. This 3 can cancel with this 3, and they're going to divide out. So what I'm going to be left with, 3 divided by 3 is 1, 3 divided by 3 is 1, you know, all you have is 1, so the answer is going to be 1. It's just trying to show you, by way of an aside example, that anytime you have numbers, or x's or y's or anything, in the top of a fraction, and you have also the same thing in the bottom of a fraction, and all the stuff is multiplied together in the top and the bottom, then you have free will in order to just strike them out. So when we do that for this process, we see that the subtraction works. And the reason the subtraction works is because what I have here in the top is 2 extra 2's than what I had in the bottom. So I can simply just, they all disappear, because when you divide them, they're going to effectively go away to 1. What I'm left with is really what the answer is going to be. But you don't have to think about all that. That's just to give you an idea of why it works. This is the real rule. If the bases are the same, you subtract the exponents. So what else do we have? Let's say we have 8 raised to the power of 5 divided by 8 raised to the power of 4. So here we have the bases are the same, so all I do is subtract the exponents, 5 minus 4. So I'm going to have 8 raised to the power of 1. And you know 8 raised to the power of 1 is just simply 8 because it's multiplied by itself just one time, so that's just the only thing there. Okay, and if you were to take 8 to the power of 5, and you would have 5 8s on the top, and you would have 4 8s on the bottom, and you would get a bunch of cancellations, and the only thing that you would have left over would be the 8 on the top, and that's why that rule works. So for one final quick little example here, what if you had 10 squared divided by 10 squared? Well, the bases are the same, so you just subtract 2 minus 2, top minus bottom, and you'll get 10 raised to the 0 power. Now, one thing I didn't tell you yet that you're going to need to remember, anytime you have anything raised to the power of 0 to 0, and no, it doesn't make sense at first, but that is by definition always equal to the number 1. Number 1. That is a mathematical definition that doesn't seem to make a lot of sense when you take 10 and raise it to the power of 0, why you would get 1, but it is a definition. It's a mathematical thing that's given to you. You just need to remember it. The details of why they define it to be like that is just something that I don't want to get into. It doesn't really help you any. It's really just something mathematicians have said, okay, we're going to have to make this definition to make everything else work. So when you have anything raised to the 0, it could be anything, 900 million raised to the power of 0. It could be x, 10x raised to the power of 0. Anytime you have something raised to the power of 0, you're going to get a 1. It's by definition. All right, so I think we have a good overview. We know basically what an exponent is. We know that when you multiply exponents, if the bases are the same, you add the exponents. We know that when you divide exponents that have the same base, you subtract the exponents.